Hello dear students of plus 2 medical, non-medical respected teachers. Today I am going to discuss third part of the chapter capacitance. In this third part I am going to discuss what are dielectrics first. So dielectrics are those materials which transmit electric field without conducting. Those materials which transmit electric field without conducting are known as dielectrics. Dielectrics are mainly of two types. Number one, polar dielectrics and non-polar dielectrics. Polar dielectrics are those dielectrics in which Cg of positive and negative charge do not coincide. In other words, they have permanent dipole moment. Those materials in which Cg of positive and negative charge do not coincide and they have permanent dipole moment are known as polar dielectrics. And this permanent dipole moment is given by P is equal to Q into 2L. And for example, H2O, HCl, NH3 are some examples of polar dielectrics. Then what are non-polar dielectrics? So those dielectrics in which Cg of positive and negative charge coincides and hence they do not have permanent dipole moment. Their dipole moment is 0. For example, H2, N2, CO2, CH4, benzene, वगैरह वगैरह. These are non-polar dielectrics. Then, what do you mean by dielectric polarization? Very important. So when a non-polar molecule or a polar molecule, when a non-polar molecule is placed in an external electric field E, then Cg of positive charge will experience force in the direction of electric field. Cg of negative charge will experience force in the direction opposite to the field. As a result, Cg of positive and negative charge gets separated. And hence, the molecule gets stretched. So more is the electric field, more is the stretching. As a result, a dipole moment is induced within the molecule. So this phenomenon of stretching a molecule under the influence of electric field due to the shift in Cg of positive and negative charges is known as dielectric polarization. So dielectric polarization means the phenomenon of stretching a molecule due to the shift in Cg of positive and negative charge under the influence of external electric field. So more is the electric field, more is the polarization, more is the stretching. So therefore, dipole moment P is directly proportional to E, or P is equal to alpha epsilon naught E, where epsilon naught is permittivity of free space and alpha is a new constant of proportionality, and this is known as atomic or molecular polarizability. And alpha has dimensions of volume, meter cube. Then what do you mean by polarization density? Since each and every molecule in the influence of electric field gets stretched or it gets polarized, and hence each molecule requires dipole moment. So total dipole moment, total induced dipole moment per unit volume is known as polarization density. It is noted by capital P vector, also known as polarization vector. So P, that is polarization density vector, is equal to capital N into small p vector. The small p vector is induced dipole moment of each dipole. Capital N is equal to number of dipoles per unit volume. Therefore, capital P is equal to N into P, or substitute the value of P, alpha epsilon naught E. So it will be N alpha epsilon naught E, or put N alpha is equal to chi. So P is equal to chi epsilon naught E, where chi is called electric susceptibility, and this chi has no units, and P is equal to N alpha. This gives relation between electric susceptibility and atomic polarizability. And chi has no units, whereas alpha has units of volume. And polarization density has units of coulomb per meter square, because n has units of meter minus 3 and p has units of coulomb meter, so it will be coulomb meter minus 2 or coulomb per meter square. So this is the units of polarization density. Then let us discuss the behavior of a dielectric between the plates of a parallel plate capacitor. So when a dielectric slab is introduced between the plates of a parallel plate capacitor P and Q, separated by distance small d, suppose x is the thickness of the electric slab and sigma is the magnitude of surface charge density of each plate, A is the area of cross section of each plate, Q is the total charge on each plate. Then E naught is the electric field applied between the plates P and Q. Now when a dielectric slab is introduced between the plates, then each and every molecule of the dielectric slab gets polarized, gets stretched. As a result, this left side requires negative charge, right side of the slab requires positive charge. As a result, an opposite field is set up. This opposite field is opposite to the applied field E naught. So this opposite field set up within the dielectric is known as field due to polarization, so which opposes the applied field. Therefore, net field inside the dielectric is reduced and resultant electric field E inside the dielectric is given by E is equal to E naught minus E. So in nutshell, when a dielectric slab is introduced between the plates of parallel plate capacitor, dielectric medium gets polarized. As a result, an opposite polarizing field is introduced which opposes the applied field. As a result, net field inside the dielectric is reduced but not zero as it was in case of conducting slab. So reduced electric field E is given by E naught minus Cp, or E is equal to E naught minus sigma I upon epsilon naught. What is sigma I? Sigma is the induced surface charge density, because sigma induced surface charge density of plate P or Q is not equal to the surface charge density of the dielectric. So sigma is the induced surface charge density, so it will be sigma upon I upon epsilon naught. Now, suppose capital P is equal to polarization density. So polarization density is defined as dipole moment per unit volume. So total dipole moment will be, then the electric will be of slab X thickness will be Qi into X, where Q is the charge induced on each surface of the dielectric. So total dipole moment of the dielectric medium will be Qi into X over A into X is the volume. So X cancels. So Qi upon A is equal to sigma I. So this is again very important relation. It means polarization density of a dielectric is equal to the magnitude of induced surface charge density, that is sigma I. So therefore, E is equal to E naught, put sigma is equal to P upon epsilon naught. Substitute the value of P from here, chi epsilon naught E. Epsilon naught epsilon cancels. So we have E is equal to E naught minus chi E, or divided by E throughout. So E upon E is equal to E naught upon E minus chi. But E naught upon E is K, dielectric constant by definition. E upon E is 1. So we have K is equal to 1 plus chi, or K is equal to 1 plus N alpha. So this gives the relation between dielectric constant and electric susceptibility, or dielectric constant and atomic polarizability. So we have chi is electric susceptibility and alpha is atomic or molecular polarizability. So alpha has units of volume and chi has no units. And polarization density has units of coulomb per meter square, and dipole moment has units of coulomb meter. Very simple. Now we will derive expression for capacitance of a parallel plate capacitor when a dielectric slab is introduced between the plates. So again, suppose a parallel plate capacitor having plates P and Q separated by distance d, sigma magnitude of surface charge density, A area of cross section of each plate, Q total charge on each plate, and that plate P is positively charged, Q is negatively charged. And suppose a dielectric slab of thickness X is introduced between the plates, which is X is less than D. Then we have already proved that each and every molecule of the dielectric will get stretched and gets polarized. So as a result, net field inside the dielectric gets reduced. So reduced electric field is given by E is equal to E naught minus EP, where EP is known as field due to polarization. Also, capacitance of air capacitor is given by epsilon naught A by D, when there is no medium between the plates of parallel plate capacitor. So this is equation number 1, this is equation number 2. Now suppose V is the potential difference between the plates after introduction of dielectric slab of thickness x less than d, then V will be equal to E naught into d minus x, because within the space d minus x there is electric field E naught by definition of potential difference, plus Ex. So E is electric field within thickness x, so it will be total potential will be E naught into d minus x plus Ex, or V is equal to E naught into d minus x plus substitute value of E in terms of K, because K is equal to E naught upon E, so E is equal to E naught upon K. So E naught can be taken common, so V is equal to E naught d minus x plus x upon K. Put E is naught is equal to sigma upon epsilon naught. Put sigma is equal to Q upon A. So then C is equal to Q upon V, that is epsilon naught A over d minus x plus x by K. So this, which is the required expression for capacitance of a parallel plate capacitor when a conducting slab of thickness x is introduced between the parallel plates of a capacitor separated by distance d. And it again proves that as x increases, capacitance will increase. And when x becomes equal to d, then substitute x is equal to d. So we have C is equal to epsilon naught A by d minus d plus d by k. So this d cancels. So we have C is equal to k into epsilon naught A by d, or C is equal to k C naught. The C naught is the capacity of the air capacitor. C the capacity of the capacitor when a conducting slab is, dielectric slab is introduced between the plates having dielectric constant K. So C is equal to K C naught, or because K is equal to C upon C naught. So as K is greater than 1, so C will always be greater than C naught. It means by introducing dielectric slab, we can increase the capacitance of the capacitor. And since molecule stretched more and more when more and more electric field is applied, because P is directly proportional to capital E, or polarization is also directly proportional to applied electric field. So if at certain maximum value of electric field, there may be electric breakdown. So to avoid this electric breakdown, we have to put certain maximum limit on electric field applied to the dielectric. So that maximum value of electric field or potential gradient, because electric field is equal to minus dV by dx. Electric field is also equal to negative gradient of potential. So the maximum value of electric field or potential gradient which must be applied to a dielectric without its electric breakdown is known as dielectric strength of the dielectric. So it depends on the nature of the dielectric. For safety, only 10% of the dielectric strength is applied to a dielectric. So this is all about dielectrics, types of dielectrics, dielectric polarization, electric susceptibility, atomic polarizability, behavior of a dielectric slab or medium between the plates of a parallel plate capacitor, and relation between dielectric constant, electric susceptibility, and atomic polarizability, and expression for electrical capacitance of a parallel plate capacitor when a dielectric slab is introduced between the plates of parallel plate capacitor, and which shows that when a dielectric slab of thickness x is equal to d, that is the whole space available between the plates is filled with electric, capacitance of that capacitor becomes k times the capacitance of similar air capacitor. So C always increases when a dielectric slab is introduced in the plates, and it becomes K times. Suppose in case of water the value of K is 81. So in case of water used as dielectric, capacitance will be 81 times the capacitance of similar air capacitor. So this is all about dielectrics and capacitance. In the last and fourth part, I will discuss Venn diagram later, very important topic. So अगेन मैनूं उम्मीद है तुहानूं सारिआं नूं बिल्कुल समझ आ गया हो। बहुत जोर नाल प्यार नाल समझाया। एक या दो बार वीडियो देख लो, अपने टीवी ते ऑन करके इनू मैगनीफाई करके देख सकते हो। सारे टर्म बिल्कुल क्लीयर ने, लगभग डेरीवेशन बिल्कुल क्लीयर ने। ते जिस तरह से फिजिक्स सीखनी चाहते हो, अगे बढ़ना चाहते हो, तो अपने दोस्तों को, अपने टीचर्स को भी कहो कि मेरा फिजिक्स कॉन्सैप्ट्स एंड मोटिवेशनल टॉक्स चैनल शेयर कर और सब्सक्राइब कर। खुश रहो, बी हैप्पी, ऑल द बेस्ट।